Hi everyone, welcome to this video on functions. Today's video is going to focus on function notation, what we mean by the domain and range of a function, and obtaining the values for the range of a function. When we talk about functions, we need to get very familiar with notation. Functions are more commonly denoted with f of x. F being the name of our function, more loosely putting it that way, and x tells us that our function is dependent on this variable x. So our function is a function of the variable x. An example of a function such as f of x is equal to 2x minus 3 shows us that our function f is dependent on the variable x, since our function is given by 2x minus 3. When we look at the function notation, there are some instances where you may not see f. They may use other notations and they may use different variables. So you may see things like g of y or even k of x. All these also indicate a function as long as the notation has a function name and a variable. Now let's talk about the function itself. Here we have a function f of x is equal to 2x minus 3. When we look at this function, it's telling us that this function f of x takes values of x and maps it onto a set of values which corresponds to 2x minus 3. When we look at this particular function, the domain of our function is going to be the set of x values that this function ranges over. When we look at the information given here, this particular information is pertinent to our domain. This tells us that the function ranges in values of -2 and 2 in its domain. So x can only be taking values of -2, -1, 0, 1, and 2, since our domain is restricted between -2 and +2. How does this affect the function? When we talk about our domain, we know the values of x that this function will take. The values of y, or our f of x values, these depend on x. And in order to determine the values which belong to our range, we need to be able to evaluate f of x at each of the values at its domain. We'll take each value of x, plug it into our function, and we'll be able to obtain all the values of f of x and be able to establish the range of our function. When finding values which belong to the range of a function, we begin firstly by selecting a value which belongs to our domain. Since our domain is restricted between -2 and +2, we can take values of x as highlighted before: -2, -1, 0, 1, and 2. My f of x values. Now typically when we've dealt with linear functions, or linear equations actually, these are examples of linear functions, and this particular function here is a linear function. We're accustomed to doing a table of values where we'd have x and y. Here, our f of x values would be corresponding to our y values. So when we find these f of x values, we're essentially finding y coordinates for these points that we're going to be plotting to create a graph of this function. So the f of x values, we start off by selecting a value from the domain, plugging it into our function. So for example, if I want to evaluate the function at x is equal to -2, I am finding f of -2. f of -2 gives me 2 times -2 minus 3. And once I can do some arithmetic, this is a simple process, and I'll be able to obtain the value for f of -2, which gives me -7. So my f of x value for -2 is -7. I can repeat this process for every value in my domain, and I will get the set of values which belongs to the range of this function, but more specifically correspond to the values of x in its domain. For the value x is equal to -1, repeating this process, I will get -5. When x is equal to 0, I'll get -3. When x is 1, I will get -1. And then finally, when x is equal to 2, I will get 1. The values of f of x are -7, -5, -3, -1, and 1. These all consist of integral values, and what we notice here is that the range of this function f of x is between the values of -7 and 1 inclusive. So if we were to state the range of our function using a compound inequality as we've done for our domain, we'll be able to write -7 less than equal to f of x, because we are looking at the values of our range.